Good morning, my YouTube viewers. It's Crystal here. I'm just here because I wanted to give you a code review of Kaggle's Playground Series 3, Episode 1. And I haven't been giving very many YouTube videos the last couple of weeks because I've been really sick with viruses. I definitely had 2, maybe even 3 viruses back to back. So I'm trying to recover from that. But I will go ahead and give you this code review because the reason why is because in the month of January there are going to be 4 playground competitions every Tuesday, which of course I didn't know that until yesterday whenever I looked on Kaggle, and then I saw that for the month of January every Tuesday they're going to have a playground competition, and then they said that they're not going to be doing it the same way that they had been doing it in the past. So rather than calling it a tabular competition, it's a playground competition. And it's Series 3, which means it's the 3rd year they've been doing it. And then this is Episode 1, which means it's the first one for 2023. So we'll go ahead and I got a score of 59%, and this was to do with a regression. So regressions, you want the score as low as possible. So I got my 59%. So this competition question is based upon the California house price data set, but it's made synthetically, and I do apologize that I had to clear my throat, but as I said, I'm still recovering. I've been sick for about a month now with one virus after another, so I'm hoping that my immunity will build up. Who knows? And then, so first thing you're going to do is we're going to read the problem statement. The data set for this competition, both train and test, was generated from a deep learning model trained on the California housing data set. Feature distributions are close to, but not exactly the same as the original. Feel free to use the original data set as part of this competition, both to explore differences as well as to see whether incorporating the original and training improves model performance. Well, I didn't do that, but I have worked on the California house price data set, and the reason why is because in Google Colab they have the California house price data set, so I've got it. So after we read our problem statement, we're going to import our libraries. And in this particular problem, we're going to import pandas as PT, which is for data processing. We're going to import NumPy as NP, which is for numerical computations. We're going to import OS, which is the operating system. It will go into the operating system and retrieve the files. We're going to import matplotlib.pyplot as PLT, which is going to be graphics. And we're going to import Seaborn, which is also graphics with a statistical ilk to it. So we're going to use OS to load up the files, and we've got our train, test, and sample submission. We're going to read the files and then use pandas to convert them to data frames. So we've got train, test, and submit. So you can see the train file. It's 10 columns of data. The mid-house val is your target. And then you've got the test file. It's 9 columns of data because it doesn't have a target. And that's what we're going to be doing. We're going to be predicting on the target. And then we've got the submit, which is what the format that Kaggle wants to see when we submit it to them. for scoring. So now we're going to check for null values. We don't have any null values, which is good because we don't have any null values. We don't have to impute them. We don't have to deal with null values, so that's good. Check for tests. We don't have any null values in tests. So we're going to analyze the target using SNS displot. And I forgot to put the KDE equals true. I forgot to do that. I was in a bit of a hurry because I've got to get these done in a week, 5 days really. So what I forgot to do was you can type in here, comma, KDE equals true, and that will give you a little, it'll give you a kernel density estimator here, which I forgot to do that. Now we're going to check for low values. We're going to check for any value that has only 1 in it, and only one value, one frequency. So if any value has only 1 frequency, we're going to delete that or remove it. So we removed all the values that have only 1 frequency. And then we check it again. And so we have less rows of data than we previously had because we're removing all of these rows of data where the target appears only once. So we check it again and it's still pretty similar. So what I did was, there's 2 ways you can do it. You can remove outliers, or you can remove everyone that has an incidence of only 1. And I decided to use everyone that has an incidence of only 1 because I thought, well, it's not going to add any meaning to the prediction if it occurs only 1 time. So that's what I decided to do. We're going to analyze our target. So now we're creating box plots. So you can check the age of the house based upon its value. That's what we're going to be looking at. The age of the house based upon its value. So you can see that the newer the house is, in theory, the higher its value is going to be, but there are some outliers, and you can see the outliers in the box plot. And we're also going to check the median income. This is the income of the house owner, and we're going to do a scatter plot on that, and you can see that there's a few outliers there. So now what we're going to do is we're going to combine our train and our test set. So your target equals train med house val, and then your combi equals train dot drop med house val, axis equals 1 dot append test. And then with combi, we're going to drop the ID because it's not necessary. And the reason why it's not necessary is because every row is indexed, so you don't need an ID number. Now we're going to analyze combi. We're going to analyze it on the longitude and latitude and make this really neat looking plot. Thought that looks good. And now we're going to create a heat map. So you can see the light colored columns have a high correlation and the dark colored columns have a low correlation. So you can see there. And then we look here, you can see the correlation between all of the columns. Now what we're going to do is we're going to normalize the data, and then what we're going to do is we're going to take the all of the values, cell values, and we're going to convert them to a value between 0 and 1 because it is easier for the computer to make predictions if all of the values are pretty much in the same dimension. And now we're going to define our X and our Y variables. Your Y is your target. Your X is column B, 0 to the length of train. And your X test is column B to the length of train to the end. So now what we're going to do is we're going to have to split the data set up into training and validation sets. And so we're going to have to create another column in X and call it target. So now what we're going to do is we're going to split the data set up into training and validation sets. So we've got our train set, which is a sample of 90% of the combi, and we've got our, or X, sorry, and then we've got our validation set, which we're going to drop everything that is comprised of the train set. So the validation set is 10%. So X train is all of the columns up until the last one, and Y train is the last column, and X val is all of the columns up until the last one, and Y val is the last column. And then we check our shapes because you want to make sure that the shape of the training set and the validation set are the same. And now what we're going to do is we're going to select our model. And in this instance, I use gradient boosting regressor, and I got a 74% accuracy. We're going to predict on the validation set, and we've got a 72% accuracy. And then we're going to check the RMSE, and we had an RMSE of 0.6. So now we're going to compare the predicted values to the actual values. And then we're going to plot our predicted values and our actual values onto a graph. So you can see that the predicted values are the dashed line, and the actual values are the blue dots. Now what we're going to do is we're going to predict on our test set, and then after we have predicted on our test set, we have to prepare our submission for Kaggle. So submit mid-house val equals prediction, then submit.toCSV, submission index equals false, submission equals pd.readCSV, submission CSV, and then submission. So this is your submission. And then we saved it and we submitted it to Kaggle, and I got a 59, which yesterday when I checked it, the highest value was a 55. So that wasn't too bad, but that's our code review. I mean, that's our code review. So it wasn't too bad. I mean, obviously I didn't score fantastic, but I scored okay for working on it for an hour or two. But in this particular competition question, you only have a week to do it, or not even a week, 5 days to do it. So I had to get it done as quickly as possible. And as you can see, there's some things that I forgot to do that I didn't do that I would have liked to have done, such as the KDE equals true, because then that would have given you another little line on your disk plot. So thank you so much for watching my video and putting up with my cough. And thank you to my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. And I look forward to making more code reviews for you in the future.